Now, this is it here for the cockpit. I'm going to put the cooler as far as silicon, flour, and baking soda. And I'm probably going to use business too. This is for the shin calf, linear solenoid motor shin calf. It corresponds to transformer coils. It is a voltage transformer and calf and shin guard. Actually, calf and shin guard. This is the shin guard for the voltage transformer. And this is for the Mark 42. This is a calf front. And I have the calf, and I'm doing that too using silicon and the thermoelectric effect refrigeration, and in the phase wires for the linear motor. So the linear motor lighting up and down, as you see in there, and I have the transformer localized outside the exterior, and it's going to be another these subsystems as far as subsystem mechanical framework, biaxial raw system, exterior as far as the armor, titanium. I'm going to be using for piezoelectric effect and pyroelectric effect. Functioning, operating as along with magnetics. It is used for antimatter when traveling in space, antimatter. And this will be used as far as anti-gravity. Linear motor. This is diamagnetic repulsive force. It behaves in a diamagnetic repulsive eddy currents. And I'm going to be using so. Okay, my name is Flymorton. I used baking soda, flour, and salt. And I'm going to add the silicon on it. This is going to be used as a fireproofer and thermal resistance. I'm going to be using silicon along with it and mix it and then spray it with adhesive and then use resin over it. Hardener. This is to the brace. I have the coils blowing in it, linear motor coils, and I'm going to cure it with it. I'm going to cure it with the epoxy resin first. Okay, so I apply the baking soda, flour, and salt, and the silicon powder that I have right here. This is a thermoelectric effect silicon, and on the top of a mesh gate bearing a linear motor like an ocean, to where all the threads are localized under as far as the coil, the inductive coil, using AWG24 board. And it's in a cage, in a mesh cage. And right now I'm going to spray with the adhesive and then use the hardener, crystalline hardener as far as epoxy resin. Shh, I'm trying to be very quiet. I can't let nobody know I got this. This is the Mark 42 board design. And the linear motors like an ocean is right there. And the synchronous induction, transduction is right here for the transformer. This is diamagnetic aluminum. And the frame, diamagnetic. The armor that goes on top is also electromagnetic. It moves the diamagnetic up in the air. So, even though this can move without the electromagnetic, through the diamagnetic, I gotta put the chain locks back on as far as the zigzag locks link that goes alongside there. Did you hear me? This is my cooler system. The coils go on the bottom, but just be quiet. Don't let nobody know. This is the solenoid linear motor right there. I gotta be quiet. I gotta go. Okay, so I gotta get larger screws to apply these, which is longer screws, so I can mount the coils under here. This is definitely not enough coils, and I have to put a series of coils on here, which have to be 3,000 per unit. So there must be 8 coils with 3,000 turns per unit. This is how I plan to house the coils, but I need the screws to go all the way through the rod. It only goes partly, so it only can fit a certain amount of coil. So I need this is the buckle down to protect it from touching the surfaces. It's located near the stage of the heatsink, and then the following the diamagnetic. So it's using diamagnetic repulsive behavior against the diamagnetic cause lift. It's actually purchasing the signal, electromotive signal, to the current carrying transduction, and that is the repulsive behavior against the diamagnetic for lift.